Our topic for today is about compounds containing oxygen and nitrogen. An alcohol is a compound that has a hydroxyl group bonded to a carbon atom. Its general formula is R2OH, where R is an alkyl group. Alcohols occur widely in nature and have many industrial, pharmaceutical, and biological applications. Ethanol, for example, is a fuel additive, an industrial solvent, and an ingredient in alcoholic beverages. Alcohols are classified as primary, secondary, or tertiary depending on the number of carbon substituents bonded to the hydroxyl-bearing carbon. Customarily, alcohols get their names by appending the suffix "ol" to the hydrocarbon. For example, methane becomes methanol. Ethers are organic compounds in which two hydrocarbon groups are bonded to the same atom of oxygen. They can be represented by the general formula ROR, where R may be the same hydrocarbon group as the other R, or a different one. Ethers, like alkanes, are not very reactive compounds, so they are commonly used as solvents. Simple ethers that contain similar R group are named by counting and identifying the organic groups, then adding the word ether. For example, in diethyl ether, diethyl accounts for the two ethyl groups. Aldehydes and ketones contain the carbonyl group. The difference between aldehydes and ketones are the substituents on the carbonyl group. In aldehydes, the substituents are R and H, while in ketones, the substituents are both R groups. Aldehydes are named by replacing the terminal E of the corresponding alkane name with Al. In ketones, the suffix ONE is used. Many common odors and flavors come from aldehydes and ketones, such as cinnamaldehyde from cinnamon bark, vanillin from vanilla bean, citral from lemongrass, camphor from camphor tree, and muscone from musk deer. Carboxyl acids are organic compounds that contain the carboxyl functional group. Simple open-chain carboxylic acids are named by replacing the terminal E of the alkane name with OIC acid. The common examples of carboxylic acids are ethanoic or acetic acid, or the acid in vinegar, and methanoic acid, which is secreted by ants, which causes the pain from the sting. Esters are organic compounds that have carboxylic acid groups in which the hydrogen of the hydroxyl group has been replaced by an alkyl group. Esters are named by first giving the name of the alkyl group attached to oxygen and then identifying the carboxylic acid. In doing so, the IC acid is replaced by ATE. Esters are responsible for many of the pleasant smells of fruits. The characteristic smell of banana largely comes from the ester isoamyl acetate, which is used as flavoring in many foods and beverages. In amines, the hydrogen atoms in the ammonia have been replaced by hydrocarbon groups. Amines are like ammonia. They contain a nitrogen atom with a lone pair of electrons, making amines basic. Amines are classified as primary, secondary, or tertiary depending on the number of organic substituents attached to the nitrogen. Amines are named by alphabetically linking the names of the alkyl or aromatic groups bonded to the nitrogen and attaching the suffix amine. The name is written as one word, and the prefixes di and tri are used when identical alkyl groups are present. Amides are derived from carboxylic acids, and their general formula is RCONH2. The OH part of the carboxylic acid is replaced by an NH2 group. Simple amides are named after the corresponding carboxylic acids by changing the IC ending or the OIC ending of the acid to amide. Amides are used in the plastic and rubber industry, paper industry, water and sewage treatment, and in colors and inks. Acrylamide and polyacrylamide are the most widely used amides. However, acrylamide is a carcinogen, so it can only be used if the chemicals are not intended for consumption. Polyacrylamide is used instead, mainly to treat drinking water and sewage. That ends our discussion for today. Thank you for watching.